All right, guys, welcome back. We're going to move into our next module, which is our SD-WAN template deployment. And we're going to talk about in this particular module, how do we define what a template is, what templates are used for. We're going to look at different types of feature templates, and there's quite a few of them that are available in the system that we can create so that we can then apply those feature templates to various device templates that we're then going to deploy to our devices. How do we actually create the device template using those particular feature templates? And then we're going to take a look at how we configure the SD-WAN device by attaching the device to the template itself. That's what we're going to be taking a look at in this particular module. Now, in the first section in the module, the first lesson, we're just going to basically take a look at what are templates in general. What are some of the parameter types? You know, there's a default parameter type, for example, a host-based parameter type, and a global parameter type that we're going to take a look at that we use in, or that we configure in vManage. There's various locations within the vManage dashboard to create these different templates. We're going to explain the use of the template variable spreadsheet because there are some specific variables that don't necessarily get applied during the template configuration phase because they would be unique variables that would apply to an individual device. Then we're going to take a look at what are the different configuration elements of a device, and then we'll wrap up this lesson and kind of do a deeper dive into template configuration and template management in the vManage system. So the first thing we want to take a look at is what is an SD-WAN template, right? Cisco SD-WAN provides a lot of different types of templates that can be used to configure different configuration parameters with one application, the vManage application, without the need to go into Cisco CLI or go into the CLI for the device configuration. Some of the benefits of having these templates is it provides for scalability for deployment, right? You don't need to enter all of the individual configuration commands on each of the devices. It's going to support that zero-touch provisioning process. The device is going to be able to pull the configuration from the template, allowing you to commission a device without accessing the console port of that particular device. We can design templates based on specific locations like the campus or the branch or the home office, maybe the data center. All we have to do is add a site-specific value to that particular CSV file. We'll talk more about the import and export of those CSV files so that we can apply specific configurations to devices that might be specific to a particular location. And we have really kind of a single controlled deployment option. Now, when you are starting to create these templates, there are a few things that you're going to have to be aware of, right? You need to know what the device is. You're going to need to know what the chassis number of the device is. You're going to have to be able to identify the active number of interfaces on the device. Maybe what type of circuits or transport that device is connected to. What is the IP addressing scheme for the device? What's the site ID? What are the host names, and so on. So what you're looking at on this particular screen here, if we go into vManage, we go into our primary dashboard menu, go to configuration, and we go to templates, we can see all the various templates that are configured. Now you notice here there's only two types of templates that exist within the vManage dashboard: device templates and feature templates. We actually create device templates to apply configurations to endpoints, vEdge devices, vSmart controllers, vBond orchestrators, and so on. We create feature templates. Those feature templates get assigned to a particular device template, and then the device template gets assigned to the device. So we can see, for example, the vSmart device template has 0 features applied to it, but it has 2 different devices that are attached to that particular template. If we go down to, say, Home V, where we have the Home vEdge 100B, that is a feature device template, not a CLI device template. We'll talk about the difference of that in a couple of minutes here, but we can see that we have 16 different feature templates applied to that particular device template, and there are 51 devices that have been attached to that particular device template for provisioning. So we've gone through many different lessons where we've talked about the infrastructure of the Cisco SD-WAN solution. What we're starting to talk about now is how do we plan our network deployments? We need to leverage a better version of something that most enterprises have been doing for many, many years in configuration, and that is templates. So think about how device templates are constructed today, right? How do we leverage them? Usually it starts with trying to create a template that's going to cover the most number of devices possible, right? Targeting the most number of devices that are going to share common parameters. A common template in the NMS, in the vManage system is the NMS template, which includes things like what are my NetFlow settings, what are my syslog settings, what is logging, what are other monitoring features, and then the enterprise will utilize that entire infrastructure. But we know that not all feature commands are the same. So templates are commonly split up based on code as well, specifically code-based. Is it iOS template? Is an iOS XE, iOS XR? I mean, Cisco Prime Infrastructure is a perfect example of that, right? You can go into a Cisco Prime Infrastructure system and go under CLI, and you can generate general configuration templates, which include various configuration commands that we can then apply to devices. If we look at NMS templates and we look at the consideration around other things, which may be the branching of templates into sub-templates, things like maybe setting up monitoring, we can see that the feature could require that we eventually have multiple templates that we actually configure. And then on top of that, if we start to look at things like the platform, right? Is it a 3900 series platform? Are we working with a collaboration platform? Is it a cube router? Does it have specific modules? If it's a 9300 switch, is it an access layer switch, and so on? So why do we really focus so much attention on these templates? Because they scale, right? They give us the ability to deploy these devices based on certain criteria and certain configuration criteria. If we didn't have templates, we'd have to go and get a configuration for each device. The potential or the propensity to make errors, misconfiguration errors, and so on is pretty high. Templates work because it's a repeatable process, right? It scales the deployment and management of devices well beyond what we would typically have. All right, so how do the Cisco SD-WAN templates compare to, say, Cisco Prime Infrastructure or so on? Well, the bottom line is that it provides the building blocks, if you will, of these configurations. Maybe I have a device template that is a feature-based device template, so I might be implementing features like security, OSPF, multicast, system features, or I could have a device template that's basically like a command line template, which includes a specific snippet of configuration commands that we can apply to the device. I guess we have to decide which one of these templates makes more sense, and that's going to depend on how different the features are on the platforms. But here's one thing we cannot do. We cannot mix and match CLI templates with feature templates on the same device. So we have to choose wisely. We can see on this particular slide that the vSmart template is a CLI-based template, Gate 1 is a CLI-based template, and the Home V templates are feature-based templates. So each template is going to share a configuration. It's going to be the same across all the devices that are attached to that particular template. But we're also going to have device-specific variables. These variables can be filled in at one time when they're deployed, meaning that if I attach a device and I'm starting to deploy that device, I'll be questioned about the specific values in the template that haven't been completed, or I can use a CSV file that I can generate, which will automatically fill in those variables for up to 1,000 devices if I choose. Right? So a CLI template might look like just a text document, if you will, that includes different command line steps or command line interface commands where we just simply attach those commands, and then that's what's going to get applied to the device. CLI templates, most closely match what most enterprises are doing today, where the template is just a basic configuration with variables that are dedicated to device-specific configurations. It gives us the largest amount of freedom to do an entire template at once, so we can replicate information across multiple devices. And it does make a whole lot of sense to have these CLI templates if we have a lot of similar devices that are being deployed in the environment. Another strength that the CLI template provides is that it will be really the first to support brand new features that maybe haven't been coded into vManage yet, but are part of the iOS that's on the platform. All right, but there's also a lot of variability in the configuration, for example, because we don't really compartmentalize the functions. And we'll see what that compartmentalization looks like as we start to get into some of the other templates. Now, feature templates work kind of more like building blocks to create a device template. They work kind of better than CLI templates, but they do require more work to implement because you have to set up multiple feature templates in order to support the device template, but they do provide a lot more flexibility. There is a lot of effort that has to go into creating each of the feature templates. The front-end work that the template provides gives us that flexibility and scalability, which lowers the effort that we have to apply on the back end. The drawback of a feature template is that they have to be modeled in vManage so that some of the newest CLI code features that might exist in the command line may not be modeled in vManage as of yet. We are going to take a look at all of the different options we have for implementing these templates in the system and taking a look at what these templates look like. The OMP feature template, for example, could include things like what are we going to advertise for routing, BGP, OSPF, external connected or static? What are the timers that we're going to use for advertise? So an advertisement interval versus a hold time, etc. All right. The main strength of the feature templates, and you're going to see this as we start to look at some of those options, is the modularity. Different feature templates can be swapped to create new device templates, where the CLI template requires an entire template to be created for each individual variant. So if I have an enterprise without a lot of variation, the CLI templates require less work to develop, but if I have a lot of features and options, then the feature template is the way that I want to go. Now, in an overlay network, like I mentioned, we might have multiple SD-WAN devices that have the same type, or they have identical configurations, or they're effectively identical configurations. So in a network, say for example, with redundant vSmart controller, each of these controllers might be configured with identical policies. Another example is a network with vEdge routers at multiple sites. Each vEdge router could be provisioned with identical services at the site, even though they might have unique characteristics that apply to each of those vEdge devices. Because the configuration for these devices are essentially identical, we can create one set of feature templates, which we then consolidate into one device template that we use for the configuration of those devices. We use the template screen to configure all of the SD-WAN devices in the overlaid network that are managed by the vManaged NMS, right? So we have Devices tab and we have a Features tab, and we see that here listed at the top. The Devices tab allows us to create device templates for our specific devices. And then we have a Create Template drop-down menu where we can click to create templates from feature templates or from the CLI. Now we talked about the difference between, say, a CLI template and a feature template. We also have the device template table, which gives us a list of all the device templates. We can rearrange the columns, drag the columns to a different position or whatever. In the Features tab, we can create feature templates for configuring software features that we then enable on our SD-WAN device. So we can go click on the Features tab, click Add Template from the drop-down menu, click to create a feature template, And then under the feature template table, we can also arrange and organize all of our features. All right, so let's go into a little bit more about some of the basic configuration elements of a template, and then in the next section, we'll get into some of the details. Now, when you first open up a feature template, for each parameter that you see within this feature template screen, they're going to have a default value. Now, the scope is going to be set to the default, which is indicated by a check mark on the left-hand side of the feature window, or the feature space where we actually select or type in the particular feature. And that means that that is a default value that's being shown. We'll see a couple of images of this a little bit later on. If I have device-specific parameters, we cannot enter the value in the template for a device-specific parameter. These are values that would have to be manually configured as the device is attached and provisioned, and it's attached to this device template, so we would be asked to enter these values incrementally as each device gets provisioned, or they would have to be attached to some sort of CSV file that we've imported that would then fill out those individual device-specific parameters. Device-specific parameters have a little computer icon or a little host icon next to them. Now the slide here says, or the description, the scope definition, device-specific values for this parameter. The value gets entered when you attach the SD-WAN device to a device template, or when you click a device-specific. When you click device-specific, the enter key box opens, and the box displays the key, which is a unique string that identifies this parameter in the CSV file called the templates variable spreadsheet. We're going to talk about that towards the end of this particular section. Actually, the next slide will be talking about those template variable spreadsheets. Some of the examples of device-specific configuration might include things like system IP address, host name, GPS location, the Latin long location parameters, site ID, and so on. All right. Global values are parameters that are applied to all the devices that attach to the particular template. Some examples of different global parameters might include things like DNS, syslog server information, interface MTUs, and so on. So let's say that I was going to go into the system and I was going to create a feature template. Like I said, feature templates are kind of the building blocks of specifically vEdge router configurations, but it could be other components in the SD-WAN architecture. For each feature that we want to enable, say for example on a vEdge router, the vManage NMS provides a template where we can fill out those desired parameters for that particular feature. So we have to first create feature templates for a lot of the mandatory vEdge router features. We can do this by going into vManage, go to Configuration, go to the Templates screen, and then from that Templates title bar, we can select the feature option, right, as opposed to device, and then we simply click Add the Template. We can now select different router models. We can create a single feature template for features that are available on maybe more than one vEdge model, but we would have to create separate feature templates for software features that are available only on one subset of routers or only on one specific platform. On the right pane now, we would select the template form gets displayed, and there's many different types of template forms that we'll take a look at. The top of the form contains fields like naming that template. The bottom contains the fields for actually defining the required parameters applicable to that particular template. Optional parameters are generally going to be grayed out, and then there's a plus sign that gets displayed to the right when you can add multiple entries for the same particular parameter. We enter the template name, we enter the template description. These fields are mandatory. You cannot use special characters or anything in these particular fields. And then for each required parameter, we choose the desired value. We select the scope of the parameter. We select the scope from the drop-down menu to the left of each parameter value box. And like I said, there are different parameter scopes. Is it the default scope? Is it a device-specific scope? Or is it a global scope? Let me see if I can kind of highlight that. We'll skip ahead a little bit here. We don't have any in this slide deck, but I'll tell you what, I'll point it out again when we get into one of our future lessons here. The next lesson we'll actually take a look at all the different parameters. But there's only three choices for parameter scope. Is it a default parameter? Is it a device-specific parameter? Or is it a global parameter? And then we can simply click the plus sign below the required parameter values to set optional values or even additional parameters. We create feature templates for each of the required features based on what those features are, right? Features could be things like AAA, bidirectional forwarding detection, overlay management protocol, security features, system-wide parameters, VPN 0 parameters, which is our transport VPN parameters, VPN 512 parameters, which is our management VPN, and so on. There's several different features, right? Some of the other features which could be included as well are things like BGP, DHCP server, IGMP, IP multicast. There's a whole list of them, right? So we'll take a look at what some of those look like a little bit later on. All right? Now, the feature templates that we're going to create are obviously going to contain variables. So to have vManage populate the variables with actual values when we attach a device to a device template to a device, we can either enter those variables manually, or we can click Import File in the upper right-hand corner to load an Excel CSV file that contains those particular variables, right? In the spreadsheet, the header row contains the variable name. Each row after that corresponds to an individual device. So we can define these variables per device. The first three columns in the spreadsheet must be in this order here. So we see column 1, column 2, column 3, and then we can add additional variables as needed for each of the additional elements, right? So the CSV device ID, that's the serial number of the device, which uniquely identifies the device. We have to be able to match the serial number because we want to be able to correspond or correlate which specific device-specific variables are going to be applied based on that device ID. The CSV device IP is the system IP address of the device, which is just basically like a router ID, if you will, for the device in the entire SD-WAN fabric that uniquely identifies that device, and then the host name of the device. So we can actually create a single spreadsheet for all the devices in our overlay network. It could include vEdge routers, vSmart controllers, vBond orchestrators. We don't need to specify values for all of the variables for all the devices. So if I have a CSV file, for example, that has, I don't know, 10 or 15 different variables, some of the variables might apply to a vEdge device, some of the variables might apply to a vSmart controller. So in those particular cases, I might decide that I'm going to go ahead and leave fields blank for variables that might not apply to a particular device. So you can actually build out this spreadsheet and then use this template to provision all of the unique variables that might exist for each individual device. Device templates define a device's complete operational configuration. The template itself consists of a number of different feature templates that we reference. Each feature template defines the configuration for a particular SD-WAN software feature on that particular device. Now, some of these features are mandatory. Those are going to be indicated with an asterisk when you're building out the template. Some are optional. Each mandatory feature template and some of the optional ones have factory default templates, and you can simply use those factory default templates as need be. Some of the features don't, and you have to create a template for those for particular features. If there is one that has a factory default template, it's going to be factory _default _ whatever the feature is _template. Or you can create your own custom feature templates that you apply. So the primary configuration elements, and we'll see this in our next section as we start to go out and look at the templates, is there's system configuration, and then there's device-specific configuration. So what is the system IP address? What is the site ID? What is the organization name? what is the vMon/DNS IP address, what is the host name, and so on. And then we have device-specific configurations like where are we applying the VPN 0 SD-WAN Fabric VPN? Where are we applying the VPN 512? That's our control plane VPN, right? Where are we applying VPN 512 for management? And then our service interfaces, which are just our basically service-facing VPNs or local LAN-facing VPNs, which are 1 through 511 and then 513 up to 65,000 and change, right? So these are things that we're going to see. We're going to take a look at this in detail in the next lesson. All right. So let's wrap up this lesson here just by summarizing what we kind of talked about. With vManage templates, we can create one set of feature templates, which we can then use to consolidate into one device template that we can use to configure all the devices. A lot of the parameter values in the templates have default values. Those parameters can then be device-specific or global parameters. Device-specific parameters include things like system IP, site ID, interface IP address. Global parameters can include things like DNS, NTP server addresses, banners, etc. And then we can actually use this template variable spreadsheet in a CSV file format that contains specific device values for each device that we can then populate and upload to vManage. So as we start to provision these devices, they can pull that information from that particular CSV template. All right, so we'll go ahead and wrap up this lesson. We'll see you guys in the next lesson.